This is Algebra 2 with Trig. We're working a 1C, 1B. We are factoring when the a value is greater than 1. Okay, now x squared has a coefficient other than 1, and we have to take into account this other factor. This value in front, we can't ignore it. So we're going to use two methods. The main method I'm going to show you is factor by grouping. We'll also discuss a little bit guess and check on a particular one that works well. So we're going to come down. We talked about a sum and product table in the past, and I'm going to use that. To make your sum and product table, we need two numbers that create a product and create a sum. The product has to be A times C. You have to include the A. So that's negative 30. We want two numbers that multiply to be negative 30, that add to be negative 1. If you know what the answers are, write it down. You don't have to make this list if you know what your factors are. If you're not sure, then you want to start making some decisions. This is negative. So to be a negative, you know your two signs have to be opposites. Okay, let's focus on this negative, I guess. This is negative, so they have to be opposite signs. And because the sum is negative, the larger number is negative. So 1 and negative 30, 2 and negative 15, 3 and negative 10, 4 doesn't go into 30, 5 and negative 6. Those are the only ways that we can multiply to be negative 30. There's an infinite number of ways to add to be negative 1, but there's only these limited ways to multiply to be 30. This, of course, is the only one that adds to be negative 1. So when the leading coefficient is not a number other than 1, we just took these two numbers and put it into the parentheses. We were done. But you can't do that here because you have an a value. So what we're going to do is bring our a value down and our c value down. That's simple enough. I can bring those two numbers down. We're going to bring the 5 over. It's a positive 5, so I call it plus 5. And I have to make it x. The x is because they're going to add together to make negative x. So that has to be an x. This is going to come over and be an x because together they have to add together to be negative x. So we made our table. We put our 5 and 6 in the middle. Now, that's the toughest part. We're done. The rest of it is back to Algebra 1, if that wasn't already. So we're going to factor out what we can. What factors out of 10x squared and 5x? 5x. What would be left if you factored out the 5x? Or if you divide it back into it, what would you need? A 2x makes 10x squared. And what's the other number that makes 5? 1. Plus 1. You have to be able to distribute it back in to see if it works. Always bring this sign down. What number can we factor out as 6 and 3? It's going to be a 3. So negative 6 times what makes negative 6x? And you really got to pay attention to your sign here. Negative times what makes negative 3? It has to be a positive 1. A lot of people make a mistake and they think that it's a negative. Notice a pattern here. What do you notice when you look at what's there? Both the parentheses are exactly the same. That is not a coincidence. They have to be the same. If you're working through a problem that they're not the same, then you either factored out the wrong number, you pulled it out incorrectly, or it's not factor by grouping. You can't factor it. That is a possibility. but it can't work. Something's wrong. So we're all done. We bring down our 5x. You bring down the negative 3, and that's one factor. You bring down one set of your parentheses, and that's your other factor. Now you have factored it apart. It will always take you 3 steps. Only 3 steps. And you have factored every factorable trinomial, called factor by grouping. Let's try again. We look at this one. You've got to make some decisions. What are we going to do first? We're going to make a table. So 6 times 10. That's the table we're using. That's 60. That adds to be negative 19. If you know what it is, write it down. If you're not sure what it is, let's figure out what our options are. The plus positive 60 tells us that the two signs have to be the same. And because we're adding to be a negative, the larger number has to be negative. So they're both going to have to be negative. If they have to be the same, and one of them has to be negative, they both have to be negative. So negative 1 and negative 60, negative 2 and negative 30, negative 3 and negative 20, that's getting close to 19, closer, negative 4 and negative 15, aha, I found it. You can stop right there. I'm going to go on just for effect, but negative 5 and negative 12, that's 60, negative 6 and negative 10. Those are your only options for getting to 60. But if you know that it's negative 4 and negative 15, you can go straight to it. What are we going to do with this negative 4 and negative 15? We're going to place them in between the A and the C. Every time. Why do you put them there? Because they add together to equal negative 19, and then you have the same equation. You can't break 19 up any other way. It has to be this special pattern, because our table helped determine that. We circle our two groups. I would like you to physically circle them. Don't put parentheses, because parentheses mean something else. We're going to circle them. Gives us, our eyes will focus in on the circle. What can we factor out of that? 2x. What's going to be left over? 2 times 3x makes 6x squared. And 2x times negative 2 makes negative 4. So that's the values that go in there. Drop down your sign. Always drop that sign down. What can we factor, or what goes into 15 and 10? We should all be confident that it's 5. Negative 5 times 3, 3x makes negative 15x. And you got to be careful here. Negative 5 times what makes a positive 10? It's got to be a negative 2, because the sign's got to match up to create a positive. Notice the parentheses are exactly the same. So that tells you you've done it right. So we're all done. 2x minus 5 and 3x minus 2. Factored it apart. Now you can check your answer. Checking your answer is always a great idea. 2x minus 5, 3x minus 2. If you FOIL this back together, 6x squared minus 4x minus 15x plus 10. Collect your like terms. And that's the problem that we started with. So you know if your answers are right. If you take a factoring quiz, you always know if your answer is right because you can check your answer. All right, what looks tricky about number 3? A is negative, and we don't like to have negatives in front of the leading coefficient. So we're going to pull that out. Do you notice anything else? So we're going to pull out a negative 2. That leaves us with a 3x squared, a negative x, and a negative 4. So we pulled out our GCF. That's what that's called. Now we're going to factor this apart. And if you can work ahead of me, you've got to make the decisions on what to do. Don't sit here and copy. Try to decide. I try to keep pausing a little bit so you can consider what's next. Our A times a C makes negative 12. Adds to be negative 1. I know right away that it's 3 and negative 4. But if you need to make the table longer, you're welcome to do that. I've shown you how to do that. So we're going to put our 3 and the negative 4 in between our A term and our C term. Now, it's never a bad idea to keep writing the negative 2, but it gets a little busy if you keep parentheses going. So I'm just going to help remind myself to bring the negative 2 down. Factor by grouping. Pull out what you can. So a 3x comes out. That leaves me with x plus 1. Bring down my sign. Factor out what you can. That's a 4. That's x plus 1 because a negative 4 times a positive 1 gives you a negative 4. The parentheses are exactly the same. I need to remember to bring my negative 2 down. If you want to physically write it as you come down, that's fine. My final answer has my 3x and my negative 4 with my x plus 1. And don't forget my negative 2. You must have the negative 2 there. You cannot throw it away. All right, this one over here, I do want to discuss the guess and check option. This one's good for guess and check because both the A and the C are prime numbers. If they're both prime numbers, you have a limited number of options that might fall inside the parentheses. So if I don't have to make a table and I don't have to think of all those calculations, this might be a pretty good method. What multiplies, if you're doing FOIL, what multiplies to give you 3x squared? It has to be 3x and it has to be 1x. That's the only way to get 3x squared. And then at the end, what are the two numbers that have to multiply to get you to 2? It has to be 1 and 2. I just don't know where the 2 goes, and I don't know where the 1 goes. So now you have to check it. You have to decide, do you want the 2 over here and say 3 times 2 and 1 times x? Is that going to get you to 1x? Or do you want to say 3 times 1, that's 3, and 2 times x? Is that going to help you get to 1? What sign would your 3 need to be? You have a 3 and a 2. You need to get it down to 1. 3 would need to be a positive 3, and the 2 would have to be a negative 2, and that would give us positive 1 if we added those two terms together. Let's check it. 3x squared plus 3x minus 2x minus 2. Those add together to be just x, and my sign is negative. That worked. This is my answer. We did that through guess and check. We did not use a table. We did not talk about larger numbers being positive and negative. We had to work our way through it all. That you can do that for every problem. We want you to do that for every problem. But I want you to understand that factor by grouping is a good method to learn and get confident with, and then we can grow into guess and check as the year progresses. All right, how about this one? Back to factor by grouping. Making our table, we're not using the box method. This is negative 20 and 1. Do you know your two factors that multiply to be 20 and add to be 1? 4 and 5. That's a very common. 4 and 5. Which number has to be positive to add to be a positive? The larger number would have to be positive. All right? So we're going to say 10x squared minus 4x plus 5x minus 2. So you put the negative 4 and the 5 in between the a and c term. You group up your two sets. Factor out what you can. You go ahead and think about that. What would be left over for the inside? And then your other term. You always bring your sign down. That's a positive. Now I look at this and I have to factor out a number from 5x minus 2. You have to put a value there, and it's definitely not 0. So it's going to be 1. You can always factor a 1 out. That leaves you with 5x minus 2. These match. So you know you've done everything correctly. So my answer is 2x plus 1 and 5x minus 2. All right, here's somewhat of a tough one. Okay, we might look at this one and think that it's a special pattern type, and we'll learn more about that. Taking the square root of your first term and taking the square root of your second term. But 8 is not a perfect square, so this is not a perfect square trinomial. We'll talk about that soon. There's not a common factor that goes into all of these. A lot of people think it's 9 because 9 goes into 9 and 18. Or it's 2 because 2 goes into 8 and 18. 2 doesn't go into 9. So we're stuck. We're going to just do the problem as it is. 9 times 8 is 72. That adds to be 18. Now, if I'm not confident on what the factors are, then let's go ahead and determine it. Now, yes, 72 is a bigger number. It's a little tricky, but I want to show you you can do these calculations without a calculator. We know that the two signs have to be positive. If they have to be the same and they have to add to be a positive, then they both have to be positive. So 1 and 72. I think we can all handle that. I hope that we all can figure out 2 times what goes into 72. 36. It's half of 72. It is a bit of a tricky one. Here's an example if we don't know. What if we don't know how many times 3 goes in? 3 goes into 7 how many times? 2 times. With 1 left over, so then 3 goes into 1 and 2, 12. How many times? 4, and there's your answer. 3 and 24 is how you can multiply to be 72. 4. Well, you can do the same thing. 4 goes into 7 1 time with 3 left over. You can do that, or recognize that you can come up to the 2, and you can just divide the 36 a second time. So it's going to be 18. That's a quick way to do it. 5 clearly doesn't go into something that ends with a 2, so we don't even have to consider that. 6, if 2 and 3 both go into 72, then I know 6 has to go into 72. 6 goes into 7 1 time with 1 left over. 6 goes into 12 2 times, so 6 times 12 must be 72. And wait a minute, those add to be 18. There's my answer. So I was able to work my way down. That's the toughest part. If you're good with your multiples, you can reach that a little bit quicker. But we're going to write down our 9x squared plus 6x plus 12x and our positive 8. Do your 2 groups. I have 3x, leaves me with a 3x plus 2. Bring down my sign. What can I factor out? It's going to be a 4. It'll never be a variable. It's always just a number. So just 4. That gives me 3x plus 2, because 4 times 3 makes 12. 4 times 2 makes 8. So I'm all done factoring. 3x plus 4. 3x plus 2. We did it. That was a tough one. Maybe the toughest one. Because our multiples got kind of large. That might happen. You just got to do your best. Now, finishing up, we have one section left, and it's about special factoring patterns. Yesterday we learned about factoring patterns when the A value was 1. Well, these names are the same thing. Difference of 2 squares. So we're going to have the same pattern we talked about yesterday. Plus or minus. When you FOIL that back together, the middle terms cross out. So just as a reminder, if we were to FOIL this pattern back together, A times A makes A squared. A times negative B would be negative AB, positive AB, and negative B squared. These two terms look the same and have opposite signs, so they cross out. So this pattern provides us with A squared plus B squared, or minus B squared. So that's how we can always factor it apart. These patterns we talked about, this would be A plus B and A plus B, which is the same term, so we can square it. If we FOIL this together, we get our A squared. AB and AB gives us that twice, and then B and B is B squared. And then with the subtraction, or the minus for the B term, these would both have to be minus. So we can write that as a perfect square trinomial. So those are the patterns we'll be looking for. Is it the difference of two squares? Or does it follow this pattern of a perfect square trinomial? So let's come on down and try it. You have 4x squared minus 9. Notice that this does not have 3 terms in it. So this is the only option that we have, the difference of two squares. Is this the difference of two squares is the question. Can you take the square root of 4x squared? And that's 2x. Can you take the square root of 9? Don't worry about the negative. Can you take the square root of 9? And that's 3. Is the middle term negative? Is that sign negative? It has to be negative. If it's positive, then it's going to be prime. If it's negative, and we have this pattern, then our answer is 2x plus 3, 2x minus 3. And the order there doesn't matter. You can put the minus first. Doesn't matter. We factored it. You can multiply it back together, and you'll see that you get 4x squared, a negative 6, and a positive 6, which makes 0 in the middle, and 3 and 3 makes 9. So foiling it back together creates the same number. How about this one out here? This is tricky. Any suggestions? What do you see? If you just start out exactly with the numbers, I totally agree. I often do that myself. So we get 3x and we get 6. So I get all excited. The middle term's negative. And we say 3x plus 6, 3x minus 6. And I did the same pattern I just did here. But we don't get full credit for that. That's because they still have a factor in it. You have to pull that factor out. You cannot leave a pair of the same number in there. Fully factor it. So I'm going to pull out this 3. Leaves me with x plus 2. This also has a factor of 3 in it. X minus 2. So those two put together makes 9. X plus 2. X minus 2. You have to pull your extra factors out. Now, some of you may have noticed, well, 9 and 36. Can we pull that 9 out in the beginning? 9 goes into 9, and 9 goes into 36. Goes in there 4 times. So then we can factor that one apart. Is x plus 2, x minus 2, and we get the same answer. If you notice you can do the GCF right away, go ahead and do that. It's your advantage. If you don't notice it and you get carried away, you just need to clean it up by the end. All right, last 2 factoring questions for the day. Now, these perhaps aren't really difficult, so we would probably just treat this as a normal problem, factor by grouping. 4 times 1, what multiplies to be 4 and adds to be 4, 2 and 2, and we'd go from that method. Totally works. But let's practice it, because there will be difficult problems in the future that you want to know this pattern. Can you take the square root of 4x squared? Sure you can. Can you take the square root of 1? Okay, so far so good. First term, last term are perfect squares. That's what this is telling us. First term is something being squared. Last term is something being squared. Okay? That's what this indicates. Is the middle term 2 times that number? So the way I like to think about it is 2x times 1 half of 4. Sure it is. So if it does follow that pattern, then you know that it is a perfect square trinomial. It happens to be this one up here because of the plus. This was a plus 4, so we're going to use a plus in between the A and the B. We don't have to think about a table. We don't have to consider factoring by grouping. We can go right into this pattern. If it follows the pattern, this is your answer. That's the advantage of it. You're welcome to use it. This is a bit tricky. I can't take the square root of 18. I can't take the square root of 2. But if I notice, there are 2's in all of them. They're all even numbers. So I'm going to factor out my negative. That leaves me with 9x squared plus 6x plus 1. You can just do it in your head if you like, but I would love to have you write it down. Can you take the square root of 9x squared? Can you take the square root of 1? When you multiply those two together, is that half of 6? All right, 3 is half of 6. So my final answer is 3x plus 1, because my x here was positive, squared, perfect square trinomial, and don't forget your GCF. Good job. Factor by grouping.